Alright guys, let's do this problem where you have to find the force in each member of the truss and state if the members are in compression or in tension. So we're going to use the method of joints to do this problem. So we're going to start here at the top. You usually want to pick one that's isolated from reactions. Remember, A and B have reactions, so you usually want to pick a spot with the least amount of unknowns and isolated. That's what you want to do. So we're going to pick D. So at D, you know that the sum of the forces are equal to 0, so sum of the forces in the X will be equal to 0. Why the X? Because we have a 600 Newton force going to the left, which means that this piece has to react to the right, which means that this one has to go down. So minus 600 plus ED times the cosine, and let's call this angle theta. Theta is equal to 0. Now what is theta? Theta, which is the same theta right here, is easily found by doing the opposite over the adjacent of the triangle, and you do the tangent inverse. So theta is the tangent inverse of the opposite, which is 8, 4 plus 4 over 6. So it's 8 over 6. And that comes out to be 53.1 degrees. So you plug in theta over here and you solve for ED, and you get that ED is equal to 1000 newtons. And as you can see, if it's going up here, it's going down here, and that means that it is in compression. Then you know that the sum of the forces in the Y also at D is equal to 0. So ED sine of 53.1 minus DC is equal to 0. So you solve for DC, you plug in ED, which is found, and you get that is equal to 800 newtons. Make a new layer. 800 newtons, and it is in tension because the arrows are going towards the inside. So now we're gonna go to C. At C. So we got this one going up, which means this one obviously has to go down. And we have the 900 Newton force going to the left, which means this one has to react to the right in order for all the forces to be equal to 0. Pretty easy. So at C, sum of the forces in the Y is equal to 0. So in the Y we got CD, which is found, minus CB is equal to 0. So obviously they're equal to each other, which means that CB is equal to 800 newtons. And the arrows are going towards the inside, so it is in tension. Now we can find EC just the same way. Sum of the forces in the X is equal to 0. We are also at C, so EC going to the right minus 900 is equal to 0. So EC is equal to 900 newtons. And as you can see, it's going towards the outside, so it's in compression. Let me turn the page a little bit. Now let me go back to EC. So basically for EC you just have to guess a little bit the directions. So I'm just gonna assume that this one's going up. I'm just guessing because that one's going straight down. And since this one's going to the left, let's say this one's going to the right. If the signs come out to be different when we do our calculations, then you know that you just flip the arrows and you're fine. So let me scroll down so I can keep this diagram. So at E, you know that the sum of the forces in the X is equal to 0. So now we gotta get a little complicated. You know this is theta, and you know that this is also theta, because you know that E is right in the middle of A and B, so those angles have to be the same. That being said, AE, which is going to the right, times the cosine of 53.1 plus EB times the cosine of 53.1 also, they're both going to the right, this one and this one right here, minus EC, which is going straight to the left, no angle, minus ED times the cosine of 53.1. And all of that is equal to 0. We got EC and we got ED. Those two are the ones who are missing. So basically you could plug in your calculator cosine of 53.1 and you could pass these values to the right hand side of the equation. In other words, clean the equation up a little bit, and you're gonna get that this is equal to 0.6 AE plus 0.6 EB is equal to 1500 newtons, of course. And let's call this, for now, equation 1. So let me draw a line right here because I'm running out of space. So sum of the forces in the Y also at E is equal to 0. So in the Y we have AE times the sine of 53.1. That's the Y component of this force right here. Minus EB times the sine of 53.1. That's the Y component of this one right here. EC is doing absolutely nothing in the Y direction, but we have a component ED coming down, minus ED times the sine of 53.1. And all of that is equal to 0. And again, we have ED, so we can clean this equation to look something like this. 0.8 AE minus 0.8 EB is equal to 800. And let's call this equation 2. So I'm going to rewrite equation 1 right below equation 2, but I'm going to multiply before I rewrite it by 0.8 over 0.6. And that's going to be, look something like this, 0.8 AE plus 0.8 EB is equal to 2000. So basically I multiplied all these terms by this fraction right here, and I just rewrote the equation 1 right below it. And as you can see, you can add both equations and the EBs are going to cancel out, and you're going to get that 1.6 AE is equal to 2800. And when you solve for AE by dividing 2800 by 1.6, you're going to get that AE is equal to 1750 newtons. And it's positive, so that means that our original assumption was right on its direction. So AE is fine. And the arrows are pointing towards the outside of the member, which means it's in compression. And then you just plug in this into equation 1, and you're going to get that EB is equal to 750 newtons, positive again, which means our assumption was right. And the arrows are going towards the inside of the member, which means it's in tension. So, final answer for EB, final answer for AE, CB, EC, DC, and ED.